Okay guys, welcome back to another video. Today we are going to prove that if a and b are integers such that the greatest common divisor is 1, then the greatest common divisor of a plus b and a minus b is 1 or 2. Now let's get started. So the first thing that I want to do is to assume that a and b are integers with greatest common divisor of 1. So we gotta let a and b be integers, okay, such that the greatest common divisor of a and b equal 1. Then what do we have to do? What I'm going to do is to let d be this greatest common divisor. So I can let d be a plus b and a minus b. So let d be the greatest common divisor of a plus b and a minus b. And try to show that d can be 1 or 2. So since d is the greatest common divisor, that means that d must be greater than or equal to 0. Now we have the greatest common divisor of the sum and the difference. I don't want to have these kind of numbers. I just want to have just like a or just b or something, or maybe 2 times a, 2 times b. So the thing that I want to do is to apply this theorem, okay, which is the greatest common divisor of a and b is the greatest common divisor of a plus bx and b equal to the greatest common divisor of a and b plus ax, where x is any integer. It's like if you have the greatest common divisor of 6 and 3, which is 3, it can be equal to 6 plus 3 times any integer, let's say 10 and 3. Or you might have, or this greatest common divisor might equal to greatest common divisor of 6 and 3 plus 3 plus 6 times minus 5. Okay, so let's use this theorem. So what do we have right now? Okay, so by theorem, okay, I will call this theorem star. So by theorem star, we gotta have d equal, let's use a plus b and a minus d equal a plus b. So I want to add the first number by integer times a minus b. So we gotta have a minus b times m and a minus b, okay, for every integer m. Okay, what can we do next? The next thing I'm going to do is to try to plug in the value of m. So right now, the expression in the greatest common divisor is some kind of, it's not simplified yet. So I have to choose the value of m so that this greatest common divisor look simplified. So I gotta try the value of m. Let's try m to be 1. Okay, since m can be any integer, you can try m to be 1. So if m is 1, then what do we have? Our d greatest common divisor of a plus b and a minus b will be equal to a plus b plus a minus b times 1 and a minus b. Okay, then what do we have here? For this term, we gotta have a plus b plus a minus b and a minus b. So what do we have? B minus b will be cancelled. So what we have left is a plus a, which is 2a, and a minus b. Okay, it's look better, right? So right now, one of the term, instead of a plus b, it becomes 2a. Now, I want to have 2b. How to have 2b? So try to let m to be minus 1. So if m is minus 1, what do we have? We're gonna have the greatest common divisor of a plus b, and a minus b becomes a plus b plus a minus b times minus 1. And then what do we have? We're gonna have a plus b minus a plus b. Okay, so a minus a becomes 0. So what you have left is just 2b. So you're gonna have 2b and a minus b. That means that we have greatest common divisor of a plus b and a minus b becomes 2a, a minus b, and becomes greatest common divisor of 2a, a minus b. What does it mean by this? So d is the greatest common divisor of these two numbers. That means that we gotta have d divide 2a, d divide 2b, and d divide a minus b, right? Do not forget this theorem. If d is the greatest common divisor of a and b, then that means that d divide a and d divide b. Okay, great. So once we have this one, let's focus on these two divisibility, the first two. So since d divide 2a and d divide 2b, what do we have? So we can have that d divide 2a times integers. So I use m already. Let's try to use x and y. X plus 2by. Okay, for every integers x and y. Alright, so do not forget that if d divide a and d divide b, then d will divide ax plus by for any integer x and y. Alright, and then what do we have next? So what we have is this. So we focus on, we have to show that d must be either 1 or 2. Okay, so what do we have? So we gotta have, so what we have is this. So we gotta have, okay, let me think of this. We gotta have d less than or equal to the dividend, right? Okay, it's got to be less than or equal to ax plus 2by. And then let's go back to this one here. Okay, what is this one? When the greatest common divisor of a and b is 1, so we have to use the advantage of this. If you have greatest common divisor of a and b equals 1, what do we have? So they exist, right? By theorem, they exist. Let's use S and T. their axis. I got it right. Their axis. Sorry. Their axis. Integers s and t such that as plus bt equals 1. Okay, so once we have this one here and this one right here, and x and y are any integers, that means that we can plug in s into x and we can plug in t into y. And let's see what happens. So if we let x to be s and t and y to be t, so we can plug in any integer x and y, right? Then what do we have? We gotta have d less than or equal to 2ax plus 2by. Now it becomes 2as plus 2bt. And we factorize number 2, we gotta have 2 times as plus bt, which is 1, right? So we have that d less than or equal to 2. But d must be, I think it's just greater than 0. Okay? It must be greater than 0. Right? So what do we have? Since d is greater than 0, so we gotta have that d will be greater than 0 and less than or equal to 2. Okay? Okay, d must be greater than 0 because 0 cannot divide any numbers, right? So the greatest common divisor of a number must be greater than 0. Okay? Now let's go back to here. Now d is greater than 0 and less than or equal to 2. That means that d can be 1 or d can be 2. The reason is since d is positive integer, that is greater than 0 and less than or equal to 2. So the only number that d can be, it can be either 1 or 2. Therefore, we have shown that. So d is this term right here, the greatest common divisor of a plus b and a minus b, right? So we gotta have the greatest of a plus b and a minus b equal to 1, or the greatest common divisor of a plus b and a minus b equal to 2. Okay? And that's it for this proof. So we have proved that if a and b are integers such that the greatest common divisor of a and b is 1, then the greatest common divisor of a plus b and a minus b is 1, or the greatest common divisor of a plus b and a minus b is 2. Okay? And that's it for this video.